Following along here, friends? Here we go. Greetings, ladies and gentlemen. We're talking about graphs of sine and cosine functions. And problem 23, they asked us to evaluate sine of 7 pi over 2 using a graph. And I believe the graphs, you could have looked them up on the previous page. Yeah, you might not even need the graph for sure. But here is a graph of that. Let's see. Oh, I need 7 pi over 2. Let me stretch this out until I've got some over 2's. Right? Wait a minute. 7 pi over 2. Wait a minute. Wait a minute.
Oh, I see.
Where's that going to be hiding? 7 pi over 2. Here's 7 pi over 4. So 7 pi over 2, I would have to like shimmy, shimmy, right? Shimmy, shimmy, right? Am I wrong? There it is. There's 7 pi over 2. And it appears as though it's all the way down at -1. So that's what we would have done.
Wait, how did you figure that out, though?
By reading it off the graph. The y value, when x is 7 pi over 2. Now, the other way you could have done it is 7 pi over 2 is coterminal. If I want to find a coterminal angle within 0 to 2 pi, I could subtract 4 pi over 2 from it.
Why 4 pi over 2?
Because that's the same as 2 pi, which is like subtracting 360 degrees. So that's the same as 3 pi over 2, right? So if I wanted, I could have said that's the same as sine of 3 pi over 2, which is like sine of 270, which would be -1. And if I wanted to look at the graph for that, you can see that the value of sine of 3 pi over 2, let's see if I can shrink that down, like Zelda Minish Cap. It's a pretty good GBA game. And you can see at 3 pi over 2, the value is, wow, that's a really good line.
No, it kind of goes up a little.
Quiet you. Is still -1. But yeah, so -1 is the value. So for most of these, it was just looking at the graphs. Your book had some on previous pages, I believe. There's cosine, right, stuff like that, and you could have figured that out. Other questions? 25.
I don't understand.
So it says, what is the value of sine pi plus cos pi?
Yeah, I don't know.
Well, can you figure out the value of either of those?
No.
Well, then let's do this together. How would I find the value of sine pi?
Can you use your fingers?
No.
I don't understand it. So please.
Sine of pi.
Yeah, I don't know. Is it sine of 180?
Yeah, that's all the way over here, right? So there's a pi degree angle. And or pi radian angle, silly me. And what would the y value be at that location? Or what's the point if this was on a unit circle?
1.
0.
-1.
-1, 0. So the value of sine pi is 0. The value of cos pi
Alright. I remember this now.
I don't.
would be
I'm
-1.
So lost.
So 0 plus -1 would equal -1.
It doesn't make sense. It does not make sense.
Because sine is equal to the y-coordinate, cosine is equal to the x-coordinate of a point on the unit circle. We also could have figured that out looking at our little chart, where you could have said cosine of pi is -1, and sine of pi, it's stuck, is 0, and then you could have figured it out that way as well. Man, I just ruined like my page. It's okay. It's okay. What's another question I got?
I'm confused why they don't put it.
I'm putting that thing on my cheat sheet.
What else we got? What's your question?
27 or 29?
Yeah.
You have the inverse.
We'll look at that as far as inverses go. We could consider
Have a
that
different pen.
from that perspective. For 27, so make sure you're writing these down, friend, so that way you're learning from our mistakes, right? That'd be a shame to make a mistake and then never learn from it, and then repeat the mistake. Would be quite a shame. It says, find the values of theta for which each equation is true. When is cosine theta equal to -1?
When pi plus
Now,
2.
graphically, this is what cosine looks like. It goes from 1 to -1. Here's my 2 pi. Here's my pi. Here is my pi over 2. And here would be my 3 pi over 2. Right? So cosine as a graph looks something like this. It starts at 1, drops down to 0, drops down to -1, back up to 0, and back to +1. Okay? So I want to know, when is it equal to -1? It appears as though that's the case at this location, at pi. All right, so that's where that occurs. And then that would happen again, how many units away? 2 pi units away, right? And it would happen over here at -2 pi units away, because this graph would actually swinging back down, and 2 pi units away, it would be back down at -1 over there. That's why you got pi plus or minus 2 pi n, or just plus 2 pi n, because I guess the n could account for the minus sign there, is where that occurs. Now, what if I did want to solve this more algebraically? If I've got cosine theta equals -1, I could, in fact, cos inverse both sides, so very good point. And so I'd get theta is equal to cosine inverse of -1. So for what value is cosine -1? Well, I guess I can't quite answer it so well here. But it would be related to this at 0. Yeah, wait a minute. Nope, -1. Yeah, I can't do the hand trick for this one. I'd have to think about the unit circle graph kind of like this. Well, cosine's -1 at pi right here. That's how I do it. And then it could be any coterminal angle with that, so that's why it would be plus 2 pi n. Because adding 2 pi any number of times would give me coterminalness. All right.
I'm feeling this is really easy, but I'm just thinking it's really hard.
Yeah, well, just keep practicing it. Sometimes just practicing a concept enough, you'll become familiar with it. Under what conditions is cosine theta equal to 1? So that's a similar idea. Well, it starts at 1, so it's 0. That's a 0. That's not a theta. That looks like a theta there, doesn't it?
It is a theta.
Yeah, that should be 0. Or just 2 pi n. Or wait. No. I don't know if I agree with their book's answer to that. Well, what's another question you guys got for me?
All you have is
No? What about it? What about any of these?
You design them.
Yeah,
No? You like those ones?
I didn't teach us
Nope,
those.
didn't learn it. Nope.
Yeah. Well, I mean, here they've got the graph going from different locations. Interesting, good stuff. Yeah, cosine equals 1. It starts at it and it ends at it over its period, right? So, yeah, that should be 0 plus 2 pi n, I imagine. But yeah, good stuff, good stuff. Well, anyways, all right, internet friends. I think we're good on that for now. So goodbye.